Modernage MCQs Physics second year, unit number 18, Dawn of Modern Physics, part 3. Which one scientists received Nobel Prize for explaining the photoelectric effect? Option A, de Broglie, option B, Compton, option C, Einstein, option D, Planck. The key is Einstein. Therefore, the correct option is C. Reason. Einstein explained the photoelectric effect successfully by extending the Planck's concept of quantization to electromagnetic waves, black body radiation, and got Nobel Prize. Hence, the scientist received Nobel Prize is Einstein. Which one of the following has the same SI units as that of Planck's constant? Option A, linear momentum. Option B, angular momentum. Option C, moment of inertia. Option D, force of reaction. The key is angular momentum. Therefore, the correct option is B. Reason. Number 1. The SI unit of A. Linear momentum is Newton second, which is kilogram meter per second. B. Angular momentum is Newton meter second, which is joule second, which is equal to kilogram meter square per second. C. Moment of inertia is kilogram square meter. And D. Force of reaction is Newton, which is equivalent to kilogram meter per second per second. Second, the unit of Planck's constant H is equal to E over F is joules per second, which is equal to joule second, which is equal to kilogram meter square per second. Therefore, the angular momentum has same SI unit as Planck's constant. Hence, the SI units of angular momentum and Planck's constant are same. The work function of a metal surface is 13.26 electron volt. What should be the least frequency of light to eject electron from the surface? Option A, 6.63 into 10 power minus 34 Hertz. Option B, 1.6 into 10 power minus 19 Hertz. Option C, 3.2 into 10 power 15 Hertz. Option D, 3.2 into 10 power minus 15 Hertz. The key is 3.2 into 10 power 15 Hertz. Therefore, the key is C. Reason. The formula of work function of metal is phi is equal to HF naught. Therefore, 13.6 into 1.6 into 10 power minus 19 is equal to 6.63 into 10 power minus 34 into F naught. We get F naught is equal to 3.2 into 10 power 15 Hertz. Hence, the frequency of light 3.2 into 10 power 15 Hertz eject electrons. The work function of a metal surface is 6.63 electron volt. What should be the minimum frequency of light to eject electron from the surface? Option A, 6.63 into 10 power minus 34 Hertz. Option B, 1.6 into 10 power minus 19 Hertz. Option C, 1.0 into 10 power 15 Hertz. Option D, 1.0 into 10 power minus 15 Hertz. Key is 1.0 into 10 power 15 Hertz. Therefore, the correct option is C. Reason. The formula of work function of metal is phi is equal to HF naught. Therefore, 6.63 into 1.6 into 10 power minus 19, which is equal to phi, is equal to 6.63 into 10 power minus 34 into F naught. Simplification gives F naught is equal to 1 into 10 power 15 Hertz. Hence, the frequency of light 1.0 into 10 power 15 Hertz eject electrons. An electron is moving with a maximum kinetic energy of 6.64 into 10 power minus 19 joule. What will be the stopping potential V naught of photocell? Option A 6.6 volts, option B 4.5 volts, option C 3.6 volts, option D 1.6 volts. The key is 4.5 volts. Therefore, the correct option is B. Reason. From the equation, maximum kinetic energy is equal to E into V naught. We get the stopping potential V naught is equal to maximum kinetic energy divided by E, which is the charge of the electron, which is equal to 6.64 into 10 power minus 19 divided by 1.6 into 10 power minus 19. Simplification gives 4.5 volts. Hence, the stopping potential is 4.5 volts. The photoelectric current depends on option A, frequency of incident light, option B, intensity of incident light, option C, wavelength of incident light, option D, temperature of metal plate. The key is intensity of incident light. Therefore, the correct option is B. Reason. The intensity of light is proportional to the number of photons. The number of photoelectrons is proportional to the number of photons. The photoelectric current depends on the number of photoelectrons. Hence, the photoelectric current depends on the intensity of incident light. A photon of frequency f collides with a particle. The momentum of photon is option A hc divided by f, option B fc divided by h, option C hf divided by c, option D f divided by hc. The key is f divided by c. Therefore, the correct option is C. Reason. The energy of a photon is E is equal to hf, and according to Einstein mass energy relation, the relativistic energy of electron is E is equal to mc square. Therefore, mc square is equal to hf, and the momentum of the photon is mc, which is equal to hf divided by c. Dividing the equation mc square is equal to hf on both sides by c. Hence, the momentum of photon is hf divided by c. The energy of photon x is twice the energy of photon y. What is the ratio of momentum of x to the momentum of y? Option A 1 to 1, option B 1 to 2, option C 2 to 1, option D 3 to 1. The key is 2 to 1. Therefore, the correct option is C. Reason. The ratio of energies is Ex divided by Ey to 2Ey divided by Ey, which is equal to 2 by 1. The relation between energy and momentum is P is equal to Hf divided by C, which is equal to E divided by C, because Hf is equal to E, or E is equal to P into C, where P is the momentum and C is the speed of light. Therefore, Ex divided by Ey is equal to Pxc divided by Pyc, or Px divided by Py is equal to 2 divided by 1. Hence, the ratio of momentum of x to momentum of y is 2 to 1. If the wavelength of incident X-rays on graphite block is lambda and scattered photon wavelength is lambda prime, then option A, lambda prime is less than lambda. Option B, lambda prime is greater than lambda. Option C, lambda prime is equal to lambda. Option D, lambda prime is less than or equal to lambda. The key is lambda prime greater than lambda. Therefore, the correct option is B. Reason: Compton, in his experiment, observed that the wavelength lambda prime of scattered photon is greater than the incident photon lambda. He also derived the same result theoretically, lambda prime greater than lambda. Hence, lambda prime is greater than lambda. The Compton shift in wavelength is option A, lambda prime divided by lambda. Option B, lambda prime into lambda. Option C, lambda prime plus lambda. Option D, lambda prime minus lambda. The key is lambda prime minus lambda. Therefore, the correct option is D. Reason: the Compton shift in the wavelength is delta lambda. It is the difference in wavelength lambda prime of scattered photon and wavelength lambda of incident photon. Therefore, delta lambda is equal to lambda prime minus lambda because lambda prime is greater than lambda. Hence, Compton shift is lambda prime minus lambda. What is the uncertainty in energy of electron of hydrogen atom in first excited state? Option A, 6.63 into 10 power minus 34 joule. Option B, 9.11 into 10 power minus 31 joule. Option C, 6.6 into 10 power minus 27 joules. Option D, 6.63 into 10 power minus 26 joule. The key is 6.63 into 10 power minus 26 joule. The correct option is D. Reason: according to uncertainty principle, delta E into delta T is nearly the Planck constant. The uncertainty in the energy is delta E is equal to I divided by delta T. In the first excited state, electron remains for 10 power minus 8 seconds. The maximum uncertainty in time will be delta T tends to 10 power minus 8 seconds. Therefore, the maximum uncertainty in energy is delta E is equal to 6.63 into 10 power minus 34 divided by minus 10 power minus 8, or delta E is equal to 6.63 into 10 power minus 26. Hence, the uncertainty in energy of electron is 6.63 into 10 power minus 26 joule.